Hi, everybody. Thanks for joining. This webinar is called Deep Dive on Amazon Managed Blockchain, and I'm Jonathan Fritz. I run the Amazon Managed Blockchain team. All right, let's begin. So, a quick agenda overall of this webinar. First, we're going to start by talking a little bit about what is blockchain technology. When we talk about blockchain, what are the elements and what are the use cases that we're most excited to help customers with in the space. Next, we'll talk a little bit about a service that we just launched in preview at reInvent a couple months back called Amazon Managed Blockchain. We'll talk about some of the interesting new features in the service, a little bit on kind of the architecture and how it works, and some ways on how to get started. After that, we'll talk a little bit about Hyperledger Fabric, which is one of the open source blockchain frameworks available in Amazon Managed Blockchain. We'll show off a quick demo then of the console and some of the things you can do with the service. And then we'll finish with some information on how to get started in the preview and then leave some time for questions at the end. All right. So let's talk a little bit about how AWS defines and describes what blockchain technology is. And we want to talk with customers who are interested in blockchain. There's a variety of different ways blockchain has shown up in the space, everything ranging from cryptocurrencies and public tokens to ledger type technology and ledger databases and everything in between. And so I always find it's a little bit useful to talk a little bit about kind of taking a step back. What is blockchain? What makes up a blockchain technology? And what are some use cases that we see emerging for this technology stack? But to kind of talk a little bit about blockchain, which is a decentralized technology, oftentimes it's useful to talk a little bit about centralized technology as well to really drive the difference between centralized database technology and decentralized blockchain networks. This kind of goes back a little bit towards before we launched both these services. We were trying to figure out what customers needed from this technology, what they were trying to do, and what use cases they were trying to address. So when customers oftentimes said, hey, we really want to use a blockchain solution, oftentimes it would be in one of two large buckets. One of the buckets of use cases was actually in the end ended up at a centralized technology. The other one, more of the decentralized blockchain network use cases. So I'll talk about the centralized one first, though, because that kind of tees up a little bit of why is decentralization important and what are the key differences between that and a database solution. So for the first bucket, the centralized bucket, customers would say, hey, we were really interested in blockchain. But when we started looking at what they were trying to do, their use case was really around, they needed a centralized solution, oftentimes maybe an internal database. And what they wanted to do was have a view of all of the state changes that happen to a system in an immutable way. And so they can go back in time and see everything that might have happened to a record to give the state of the world as it is today. And so customers today had that use case already to some degree. They were running, a centralized MySQL database, but the way to get that view back in time in a tamper-proof way was having audit logs, securing those audit logs, finding a way to query the audit logs, and that whole process was a little bit clunky to do. And so oftentimes those customers would go and look at maybe blockchain as a way to solve it because they heard about blockchain having a ledger database component, the ledger having a immutable journal, which is basically the immutable change log of all these transactions that happened leading up to, say, where the current state of the world is today. The problem with that, though, is that, remember, they were looking for a centralized solution where blockchain is decentralized. So blockchain, because it's decentralized, has added complexity, some performance degradation implications because it's meant to be on a network where unique organizations are achieving consensus versus a database which is wholly owned and doesn't need to do that. And also just the general technology stack is a lot less mature, that you've got a lot of new, very interesting technologies, but they're not as mature as existing centralized database solutions, either relational or non-relational. So these customers are trying to use blockchain, but trying to use it for a centralized solution, having some issues. So for that use case, we released a service called Amazon QLDB, Quantum Ledger Database. That service is in preview. We also announced that at reInvent. And the goal of that service is it's a ledger database service to make it very easy for customers to run applications that have, that utilize the ledger, that has this, if you want, this immutable history of everything that happened. You can use QLDB and have that back your application. And so that's great. That solves that centralized use case. However, in the second bucket of customers, there's a different themes that kind of showed that centralization and centralized use cases or technologies wouldn't be the right ones to fit those use cases. And here are a couple themes. I won't go through every single one, but I think you'll see some of the patterns that we saw in showing that centralized ledger database wasn't necessarily the best fit. And so the first use case, many existing business networks that exist today rely on central authorities, where I might want to transact as, say, I'm company A, transact with company B directly. But instead, I go through a central authority that we both trust. And the problem with that is that it's inefficient, because instead of transacting directly with you, now I have to go through this other entity that's slower, and it's expensive because they usually take a cut. And oftentimes I'll have to audit them and audit you as well to make sure that whatever was supposed to happen happened in the way that it was supposed to. So once again, added inefficiencies and costs for trying to do a transaction between two entities in or groups of entities. A second use case that, once again, a centralized database, centralized solution isn't the best fit, is one around a consortium, so a group of organizations that could maybe achieve a better outcome by sharing information. But the problem is, no one could really figure out who owns the IT system and who owns the database. That I might say, I'll start this group together, I'll own the database, I'll give all of you access. Other folks, though, in this group might not want me to have own the database and have all the access to it. Everyone can't own the database, because then it's just difficult to set up a way for everything to stay in sync, because these are kind of data silos. And then oftentimes what happens is we start talking about maybe creating a joint venture between all of us, and that new corporate entity is the thing that owns all the IT. And that's obviously a lot of overhead, when in reality the use case is quite simple. We just all want to share information in a way that I can independently verify the data set and what's going on. And there's a few more things in your themes as well. Once again, the themes around multiple organizations trying to do something together, either transact or share information, maybe wanting to have a single view of a process that every organization owns a piece of. It could be something around business logic and automation that affects multiple organizations in a transaction, but needing to verify easily and independently that whatever happened in the way you thought it would. Or kind of a public network that can be used as a utility that not one person owns to maintain the state of something, or show that something had happened. So, at a high level, we started seeing a lot of these themes, these use cases where customers were trying to, groups of customers were trying to do things, and each kind of needed a seat at the table in building these systems, and that kind of didn't really work well with the paradigm of somebody owning a database technology, even if it was a ledger. And so, that was kind of some of the use cases that made us say, look, this is a separate set of use cases than the ones for centralized ledger database, and this is a case for decentralization. And so how Amazon thinks of blockchain in this case is eliminates the need for a central authority in a business network, and enables groups of customers, to transact and share data and independently verify what's going on in a trusted way. And it really takes a system like you see on the left to one on the right, where really everybody is an equal seat and can interact with each other directly. So that's kind of a little bit on how we think about blockchain. And I want to dive into the three main components when we talk about blockchain technologies. We say make up a blockchain technology. That sometimes you see, blockchain. People say blockchain is a ledger. We actually say blockchain has a ledger in it. A ledger database is one of the components, but it actually has more of a layer cake, where you have the ledger as kind of the bottom component, then a consensus mechanism on top, and then finally the top portion of that technology stack is the smart contract execution environment. So we'll kind of quickly go through each component. So first, at the base, a blockchain has a ledger database in it. And the journal, which is the hash-chained blocks of transactions that make it kind of the immutable changelog of everything that happened, is where the quote blockchain technology got its name. It's a chain of blocks. We call it in kind of when we talk about ledger databases, though, we call this the journal, which is the immutable log of all the transactions. And then kind of taking a step back on what consists of a ledger database, you've got the journal and the current history. So if you think about it kind of like a bank account, the journal is all the credits and debits that happen to your account, and the global state is your balance. And so both are very important. Oftentimes an application will be reading a lot from the current history because that's kind of the most relevant thing to what an application is doing. But at times where you want to see everything that happened to get to that current view, or want to make sure that nothing was, say, tampered with, you can go inspect the journal and see exactly everything that has happened. This is kind of also a slide that you can see in a QLDB presentation as well as a ledger database. But one big difference between a blockchain and a ledger database is that every organization in the blockchain has its own copy of the ledger database, which is important because that means that everybody in the network kind of controls their own destiny, so to speak, has access to the data. There's obviously some semblance in different blockchain frameworks of access control, but it's not like one person did the database and is sharing with everybody else. Everybody has a copy of that ledger so it can independently verify that the data is what you thought it was. So on top of the ledger database is blockchain framework has consensus mechanism. And there's a bunch of different ways blockchain networks achieve consensus, the idea of what is the state of the network and what gets written to everybody's copy of the ledger. The consensus mechanisms for like a public network are very different from ones from a private network where you know all the members who are in it. Part of that reason is public networks try and solve against something called Byzantine fault tolerance, which is has to do with the fact that you don't necessarily know information that you're getting because it's public. It could be anybody on the network, and there could be some malicious users. As a way to kind of trust, a way for the network to guard against malicious activity and put the right things into the ledger versus, something that a transaction that a malicious user might want committed to the transaction history. But this takes a lot of power. You might have read also in the news some of these public networks like Bitcoin taking up a lot of power to run these algorithms for the network and achieve a consensus. Also, somewhat poor performance. On the other hand, for private networks, you don't have to guard against this problem of a random organization coming up. The private network might be a consortium of banks, where you know all the enterprise customers who are part of that part of that consortium. So in that case, you don't necessarily need to guard against Byzantine fault tolerance. You can have consensus mechanisms that have better performance. They can do more transactions per second and use less power. So the final layer at the top. So we talked at the bottom you've got your ledger database that every entity in the network owns their own copy of. On top of that, you've got a consensus mechanism, the ability for a network to decide what gets written to the ledger and what the state of the network is. And then the layer at the top is a smart contracts component. When you think about what the blockchain network actually does and what people are deploying on it, customers are writing application code that gets executed on the network in a verifiable way. And so this enables lots of interesting use cases in blockchain because it's not just debits and credits. In fact, these networks are running interesting applications, or called smart contracts, you could say as well, that get triggered with certain preconditions and then can do all sorts of arbitrary work, making it useful for use cases ranging from supply chain to financial services. Smart contracts can also interact with components outside of the blockchain network as well, and there's a lot of interesting work being done in how to create smart contracts and enable more things that they can do. They can interact with IoT devices, other storage systems. You might not want to, say, store an entire object on the blockchain or PII information on the blockchain, and so this contract can maybe store a hash of that and a pointer to where, say, an object is, store that metadata on the blockchain, and then when you retrieve the object, it can check against it to make sure that nothing has changed. So there's a variety of interesting things that are going on in developing contracts to integrate with other components, and we're seeing a lot of solutions kind of expanding beyond the blockchain to build a full stack. So There are two main types of networks: public and permission networks, and there are different blockchain technologies, frameworks that are kind of enable both. And some overlap. Some you can make private and public networks in as well. The public networks allow anyone to participate in the network and run a node and help the network achieve consensus and store a copy of the ledger. And members are incentivized to buy a computer, install the software, pay for the power, and help maintain the network by having the chance to mine cryptocurrency. And that's where Bitcoin mining or cryptocurrency mining, what's going on is these nodes are fighting to, win the right to add the next block to the ledger, and then you get rewarded for the effort and cost that it was to you. You'll probably recognize some of these logos here. There's Bitcoin, Ethereum, Litecoin, and there's a variety of other networks out there as well. But the key is, anyone can join, anyone can transact on them, and you can earn cryptocurrency for mining and maintaining the network. On the right, you'll see a somewhat different set of logos, and these are some frameworks that are meant more for permission networks, where all of the members who are trying to transact and share data. And a lot of these are more enterprise use cases where you've got consortiums of banks or different entities on a supply chain. These permission frameworks, they don't have an embedded cryptocurrency in them because the business externality for wanting to run the hardware and software and be part of the network is some business externality, like my supply chain is 10% faster, or it costs less money to clear a transaction in a financial services context or something like that. And so it's a little bit different than some of the public networks. And we're seeing lots of interest in interesting use cases across both. And it really is true. Customers are experimenting across many different industries in using these technologies, and ranging from the largest enterprises and Fortune 100 companies to small startups, trying to think about how to utilize decentralization and maybe change the architecture of current processes to become decentralized, or even invent kind of net new ways of doing things to make whatever these transactions or systems are more efficient, cheaper, and more transparent. You could spend a lot of time on this slide because there's so much experimentation, interesting work going on. But I'll highlight a couple of interesting ones. Once again, kind of all the themes that we talked about on the earlier slide about organizations or groups of customers trying to work together to make transactions easier, more transparent, and cheaper permeate a lot of these different industries. So ranging from patient records, the idea that there's a lot of data silos in hospitals and a lot of inefficiencies. Could you utilize blockchain to enable hospitals and payers and providers to share information easier, increase transparency and quality of care, and make healthcare cheaper and better quality for folks in the system? And so there's a lot of interesting work being done there, and also interesting ideas around privacy laws and other things when building these solutions. There's ideas around in digital advertising being able to code payments for clicks and ad technology in smart contracts to easily show what's going on, who's getting paid, and verifying exactly the quality of certain ads being shown in customers' interactions with them. In real estate, a bunch of interesting things ranging from trying to remove escrow, which is costly and inefficient from real estate transactions, to new asset classes in real estate and other things like that kind of are enabled by making real estate assets digitized on the blockchain. And then finally, proof of ownership is another idea of kind of thinking about assets on the blockchain and who owes them and transferring ownership. And finally, there's a lot of interesting digital identity things as well that, if you have groups of entities like, say, in issuing a loan where you've got different people with different credit scores and different information, but a lot of different organizations among the chain that goes down to issuing the loan, is there a better way for all of those organizations to share information and be able to better qualify folks applying for a loan and do it much more quickly versus a lot of the manual kind of paper shuffling that can happen, especially in some markets in the process. We'll highlight a couple of verticals where we see some early adoption and that we're particularly excited about. One is blockchain and supply chain. And if you think about supply chain, you've oftentimes have these massive global supply chains that involve many suppliers, partners, shippers, things happening cross-border, exchanges of goods and services. And it can be difficult for any one entity to have this kind of single pane of glass to view their supply chain through. And there's also other things around efficiency. If you can shave off a certain percentage of efficiency on supply chain, you can save money, provide a better quality of service. And also the idea of, in the case of, say, a recall where certain components might need to be recalled, or, if it's food, certain maybe crops that are ended up in the end product, there's some issue with that. Being able to figure out how to recall certain things and figure out where the kind of problematic upstream components ended up in the downstream product. And with reputational risk, that could be huge to shave off, if you could recall something immediately versus waiting a week. It could mean a lot for brand trust as well. And so there's a lot of interesting work being done to say, instead of kind of the data silos of supply chains today, would there be ways to utilize blockchain to make things more efficient and make more things automated as well and more traceable. And so we're seeing a lot of excitement here in customers starting to work to leverage these things to improve their supply chains. Another vertical where we see a lot of activity in blockchain from our customers is in financial services. And focusing here less on the cryptocurrency stuff and more on the enterprise use cases. And we kind of talked a little bit about them a couple slides back, but the idea of groups of financial customers creating new asset classes, or being able to track identity for loan issuance or other services as well across different bank divisions, or more importantly, from a decentralization point of view, across different banking institutions as well. Utilizing blockchain as well for digitizing different securities and making them more easily tradable, or credit swap type use cases as well. So once again, things that involve multiple financial institutions trying to work together and eliminating central authorities, or coming up with new ways to transact where everybody can independently verify what happened and trust in the consensus building of the network. So we talked a little bit about kind of how AWS thinks about blockchain, the difference between centralized ledger, a decentralized blockchain network, what a blockchain technology consists of. Remember those three components: ledger database that everyone owns, consensus mechanism, and then at the top, smart contract engine, and then some use cases. And you can probably see also why customers are getting so excited to figure out ways to utilize decentralization and blockchain networks in their businesses. But we got some feedback from customers over the last couple of years about, hey, we really like these use cases, we want to get started, but it's really difficult to get started. That to create these blockchain networks, even if it's a POC environment where I own all of the components and maybe simulate multiple organizations, you've got to provision hardware, I've got to configure pretty complicated open source software and complex networking with some frameworks like Hyperledger Fabric. I've got certificates, and if I'm going to try and run something in production, I need to figure out a way to secure it, so I need maybe an HSM, ways to govern access control, monitoring and management of these systems is a kind of some of the complexity around distributed systems and managing them appear obviously in blockchain, but you also have then this decentralization where somebody else owns some of the components. And so how do I think about managing the components I own, but then keeping the network healthy when other folks have some of them? How do I add and remove members in the network securely if it's a permissioned one? How do I scale the performance? And utilize this technology. And so we're getting a lot of this feedback. Earlier last year, around April 2018, we launched our blockchain templates to make it easy for customers to create test environments for with some of the open source frameworks to get started. But customers still wanted a way to build more robust POC environments and making it easier to use, and then scale those and that same stuff to production across multiple AWS accounts. So a couple months back at reInvent, we were proud to announce a preview of our new service, Amazon Managed Blockchain, which we built to really make it easy for customers to utilize blockchain to make a difference in their businesses. Amazon Managed Blockchain is a fully managed service that makes it easy to create and manage scalable blockchain networks using popular open source frameworks, Hyperledger Fabric, and Ethereum. Based on customer conversations and a bunch of the use cases that we were diving in with them for, Fabric and Ethereum covered a lot of that, ranging from the private blockchain use cases, which we see is more natural for Fabric, and some of the use cases with public networks, which lend themselves more to Ethereum, although Ethereum could be used for private networks as well. I'd like to go over a couple of the features that in Amazon Managed Blockchain. First, it really is fully managed, that you can create a blockchain network in 10, 15 minutes. And Amazon Managed Blockchain, in a couple of clicks, deploys all of the software, hardware, networking, enables you to create a network and then invite the other AWS accounts that you'd like to join. Amazon Managed Blockchain offers two open source frameworks, Hyperledger Fabric and Ethereum. We'll go into those a little bit more later in the presentation, but they cover a wide variety of use cases, offer different smart contract programming languages as well. And there's some other differences that make it so that a variety of different use cases can be addressed across both. This one's interesting, decentralized. And so when we talk about blockchain earlier, the idea that a network really has a group of organizations coming together, but that not any one organization has necessarily any more power than any of the others. But if you think about kind of from the typical cloud resources model, if I say I had an S3 bucket and I enabled all of you to upload objects to it or download objects, you'd have access to the data, but at any given time I could cut off your access because I own it, or I could shut down my account, and then all that information is gone and deleted. But in a blockchain network, that would give one person, maybe the initiator of the network, more power than anyone else. And so the service actually enables you to not have that issue by outliving or being available beyond the person who created it. And what I mean by that is, if I create a blockchain network, invite all of you, and then I leave the network, maybe I terminate my AWS account, that network is still fine, and everybody running it that can continue on with the network, that there is no given owner for that blockchain network. No one owns it. Now, you could configure it to where there is an owner. There might be some use cases where you're really using it more for the data integration aspects. And if I say I create the network and I want to terminate it when I'm gone, that is configurable. But in many of the use cases where you're really utilizing it as a decentralized system, this concept is important. And so we built that into the service, where the organization can also vote on who to invite, who to remove, and some of the voting rules as well, really making it democratically governed. Another feature, increased reliability and scalability, that we with Hyperledger Fabric increase the reliability and durability by utilizing the same journal technology that backs Amazon QLDB in a component called the Fabric Orderer, which is an important component that takes some of the transactions, batches them up into blocks, and then sends them back out to all the organizations. It's a critical piece of a Fabric network. In open source, Apache Kafka is used, and Kafka is a great open source project, and out of all the open source project, lends itself the best for, if you're running, say, open source Fabric, a highly available way to back the ordering service. However, Kafka really isn't built for the actual way that the ordering service needs to utilize it, like storing all the history of the transactions in a durable way long term. So we felt that utilizing the same journal technology back in QLDB offers customers a more durable way to run Fabric, and that's running in the background. Amazon Managed Blockchain is low cost. You only pay for the resources used. It's pay as you go, and we'll talk a little bit more about the pricing model in a minute. And then finally, it's integrated. That you're able to take information in near real time of events that are happening on the blockchain network and pump that into an Amazon QLDB ledger that you own, that's running outside of the network to use as maybe secure off-chain storage, or to do additional analytics on without impacting the components that are running the blockchain network. Now, some of these features, like the voting and decentralized governance of the network, and integration with Amazon QLDB for off-chain storage and analytics are coming soon in the preview. They're not currently available, but we're adding new features every week to the preview, and those will be available soon. So a quick look, deeper look at the Hyperledger Fabric framework. Fabric is really meant to create permission networks where you know all of the entities that are in the network, and it utilizes channels, which we'll talk a little bit later, to limit who can see what information and participate in what transactions. Fabric runs Chaincode, which is smart contracts. Is available for a couple of different programming languages, and there's a bunch of kind of customizations you can do in validation policies and other things like that. So there's a lot of different levers you can pull to customize exactly the way the Fabric network works for you. And finally, there's no native cryptocurrency. Remember, this is a private network, and so you don't need that incentive cryptocurrency embedded in it to make the network run. Ethereum is another open source framework, and that's currently not available in the preview, but it's coming soon. Different smart contract language, very popular one though, uses Solidity to write smart contracts. And Ethereum is very, very scalable. The public network is thousands of nodes. In Ethereum, unlike Fabric, you can create a permissionless network, one that's open for the public to go join. And in Amazon Managed Blockchain, you'll be able to run nodes that will connect to a public Ethereum network, as well as create your own private networks as well. In a private network for Ethereum, you can use different consensus algorithms to make things run much faster, because you're not guarding against Byzantine fault tolerance. Ethereum, obviously there's many use cases for the public network. From a private network, there's use cases as well. I think one thing is that it doesn't have the same set of access control features as you'd find in Fabric. So, we'd say that for some use cases it makes sense, but you're typically simpler and ones that involve less access control features that are required. It really is that easy to create a network. I'll show in the demo in a few minutes on kind of exactly how to do that from the console, but really in a couple clicks you can create a network, invite other AWS accounts to join you as members. Everyone adds their peer nodes, and then you've got a functioning blockchain network up and running, and then you can deploy your applications. Here's a quick view of kind of the architecture of what's provisioned when you create a managed blockchain network. And so I won't spend too much time here, but I think it's helpful to kind of see from the AWS architecture view what's going on when a network is provisioned. And so if you think about it, member A, member B, and member C are different AWS accounts. So they're different organizations. They're not all databases in the same account. They're different accounts. However, you can, in a single account, create multiple members. So if you did want to simulate what a 3-member Hyperledger Fabric network would look like, you could easily provision this in one account as well. When a network is provisioned, let's say member A provisions a network, so ignore the member B and member C components up on the screen. The kind of blockchain network's created. There's a VPC in the service. There's Hyperledger Fabric ordering service that's used for the network that's created. Remember, that's that shared component that all of the members in the network use. Member A is provisioned, and the member A resources are the Fabric CA, which is holds the root certificate for the organization. That is kind of the definition of the organization on the network. All the users or transactions the network does utilizes certificates, and that certificate, the root in the chain of trust, is held in the CA, and that defines kind of the different entities in member A. You can also provision peer nodes, and we'll talk a little bit more about what peer nodes do later, but they store the ledger endorsed transactions for each member. And then also what's provisioned is, if you can see on the right, an AWS VPC endpoint service. And that actually enables each account that's in the network to create a VPC endpoint in their own account, so that their client machines, because when you want to interact with the Fabric components that are created, you download the open source Fabric SDK. We didn't modify it and make Amazon Hyperledger Fabric. It's, we're running the open source components, and we're staying true to open source. You download the client, you can run it on an EC2 machine in your VPC, and then go directly through the VPC endpoint you've created to interact with any of the endpoints exposed to these services. And that's important because we're not opening up the ordering service endpoint or your pure node endpoints, your C endpoint to the internet, that you can interact with it directly through a VPC endpoint. So you're running your client application, your client machine in a VPC you own. One actually other important thing about the networking is that for endorsement policies that require you to get an endorsement from organizations that are not your own, let's say 5 out of 7 organizations need to endorse the transaction in the network, or in this case, maybe 2 out of 3, your client doesn't need to just talk to your resources, your peer node and Fabric, or it doesn't need to interact with Fabric CA, but your peer nodes. It needs to interact with the peer nodes from the other members as well. And so the networking sets up where out of the box you can do that. You don't have to configure any other networking. You don't have to do any VPC peering or anything. That your client machine, through that endpoint that's provisioned as part of the service, can interact with all the things it needs to in a secure way. So once member A is created, you can invite member B and member C, those AWS accounts, to create their resources. They can accept the invitation, and then when they join the network, a Fabric CA with their root certificate is provisioned. And one other feature that we have is that the Fabric CA store, the open source, the root CA, the certificate's just on whatever machine you've provisioned, and that's why oftentimes, if you're running your own components, you would need to get an HSM. Amazon Managed Blockchain, all the Fabric CAs are secured by HSM grade technology and utilizes AWS KMS under the hood to secure your Fabric CA. So that you get that out of the box when you're using the service. But anyway, member B and member C provision their components, and then they can create their own VPC endpoints and run their own client machines in their VPC, and then you have a fully functioning Fabric network. So all this can be done in a couple of clicks to easily create a network, but also run it in a secure fashion. Going back to who owns the network, and that's that idea of decentralization. The answer is no one really owns it, or you could argue that everybody owns it. I can create a network, and based on the voting rules, the policy could be majority rules, could be unanimous vote. It could be that one person gets to decide everything. Obviously, that's not a decentralized use case, but there are some use cases for that. That's all configurable, and so in the preview right now, those features aren't available, but they're coming soon. And the network can vote on who to invite, who to remove, and even change the voting rules of the network as well. So moving on to pricing. So it's pay as you go. There's no upfront costs. And the goal is to make it very, very affordable to test all these use cases, try a bunch of different POCs, and then scale that same architecture up to production in a cost-effective way as well for customers. There's a couple of different dimensions. There's an hourly rate for your membership in a network and a peer node that you create. Right now in the preview, we limit the hardware you can use, but there'll be a variety of different instance types that you can use for your peer nodes depending on the transaction volume that you think you might have or the complexity of those transactions. But you get billed per second for those resources. You also get billed per gigabyte of data written as well. So depending on how much you're writing to the network, there's a charge for that as well. And then finally, when you create that VPC endpoint, you're charged separately for you're creating the VPC endpoint, and then standard data transfer rates apply. So truly is pay as you go. And the goal is as you scale your use case, you can add more and more components, and then it's still pay as you go for the amount of resources that you're consuming. For Hyperledger Fabric and Amazon Managed Blockchain, there are 2 editions, Starter Edition and Standard Edition, and both are production grade. That if you have a use case that's, say, a smaller scoped use case, the Starter Edition is totally fine. We're using HSM grade technology to back the Fabric CA in both cases, highly available components for both. It's just Starter Edition, you can't scale the network quite as wide. There's less peer node hardware you can choose from, and supports a slower transaction rate. However, for many use cases, you don't need a high TPS, and this would be a great way to lower your costs for that use case. Standard Edition is for larger scale networks, higher transaction throughput, and there you can have up to 30 members per network, more peer nodes per member, more instance types to choose from, and a more robust and higher throughput ordering service. So the membership pricing rate is different for each edition, and all of our pricing is available on our website. However, in the preview right now, we are not currently charging for usage. So real quick, let's take a deeper look into Hyperledger Fabric. Hyperledger Fabric right now is available in the preview, is one of the frameworks we support, and is really used for permissioned networks. And real quick, going through a transaction flow, it's kind of useful when thinking about, all right, well, there's all these different interactions with different components, what's going on. And so oftentimes I think it's useful to walk through the transaction flow of when you submit a transaction to the network, what's going on. So, and how that maps to some of the managed blockchain components that we just went through. And so here you can see on the left, starting with submitting client, that's running on an EC2 host and a VPC that you created that you own. And so when, say, you want to propose a transaction on your blockchain network, you've already created your membership and the network's already running. That submitting client will submit a transaction proposal to peer nodes from one or more networks. That depends on the endorsement policy you have. So let's say 5 out of 7 organizations, the network members of the network need to endorse it. So your client machine will go hit the endpoints exposed for all those peer resources through the VPC endpoint and submit the transaction proposal to those peers. Each peer will simulate that transaction, decide if it's endorsable or not, if that transaction is something that is correct. And assuming that it is, we'll send back an endorsement signature back to the submitting client, which remember is running on that EC2 host in your VPC. The submitted client is collecting these endorsement signatures, and once it has enough to pass the validation policy, it sends the transaction with the endorsement signatures and some other metadata to the ordering service, which is, remember, that service that all of the members use and jointly own in the blockchain network. The ordering service verifies that the transaction's okay, and once it gets enough transactions or a time threshold's hit, it bunches those up into a blocks and then sends the transaction back to all the peers in the network. Peers then get the transaction, validate that in fact it's still good, so it goes and decides to either commit or not commit that block, depending on there's some round trip time. So if the world has changed in between there and would make it invalid, the peers then do one last check. And then once that block is committed to the ledger, the global state database is updated, and that transaction has been committed. So that's a quick kind of flow through, when these transactions are happening, what's going on. It's also kind of a good way to think about resources on the network. How big a peer node do I need? How many peers? Thinking about exactly all the things that could be happening based on your transaction throughput. We already talked about this a little bit. We've augmented Hyperledger Fabric. We've utilized the same journal technology that backs Amazon QLDB for the ordering service instead of Apache Kafka. And when we run the Fabric CA, we're not using a soft HSM like you would in an open source without configuring a secure certificate store. We're utilizing AWS KMS technology to secure the CA. Hyperledger Fabric utilizes Chaincode. It supports 3 languages: Go, Node.js, and Java. It's executed in a Docker container on peer nodes as well. And there's a lot of kind of interesting work that's being done in Chaincode. We've got some example Chaincode in our documentation and on a post on our AWS database blog, and there'll be links at the end of the presentation if you're interested in checking out what some sample Chaincode looks like. Each member on the network has one or more peer nodes. And remember, each peer node stores a copy of the ledger. And so that enables everybody in the network to essentially own a copy of the data that they should have access to. Which is different than me exposing a database to you. Everybody owns their own data and owns their own destiny. You install Chaincode, so these smart contracts, on a peer node, and then you invoke them. Peer nodes also endorse transactions that are on the network and then validates transactions before the final commit to the ledger. Hyperledger Fabric has a couple of ways to do access control. You might have a known consortium, you might know everybody in it, but you might not want every single member to have access to all the same data. That you might want some access control and permissioning over different parts of the data. Channels is one way that Hyperledger Fabric does that, where, like, as you can see in this diagram, it's kind of like a sub-ledger that members 1 and 2 are part of channel 1, 2 and 3 are part of channel 2, and the transactions going on in each of those channels are only privy to the people who are invited to join those channels. Fabric also has a feature called private data, which enables even like kind of a more granular access control within a channel to make sure that transactions can be kept private for certain members that are transacting at a sub-channel level. So real quick, I wanted to run you through the console, just a quick look. And if you sign up for the preview, you'll be able to access the console in the same way as well. So let me quickly open this up. So once you're whitelisted and added to the preview, once again, you have access. You can use the CLI or AP, the CLI, the SDK, or have console access. And it really is that easy to create a blockchain network. You see, here's the landing page. You can click Create a Network. You choose the framework you want. Ethereum's coming soon. Right now, we've got Hyperledger Fabric. You add in the network name and description. So we can call this FritzNet description test. Go to hit next. And then when you're creating your network, remember, you must create your member first. You can't have a network with no members in it. And so you create your initial member. In this case, here are the, say, member name, John Fritz, description test. And then when you create your member, you also create the Hyperledger Fabric CA that defines your organization, and you need to provide the admin username and password so you can manage the network, create more users, and that's kind of like your database admin, so to speak. So we can quickly add in the username and password here. Then you hit next. And then you hit Create Network and Member, and Amazon Managed Blockchain takes care of the rest of the provisioning, all the shared components, the order, the networking, the Fabric CA. And within minutes, you've got the network up and running, and you can invite other accounts to come and join. I've actually got a network running right now, so you can take a quick look. This is what it would look like once the network's running. As you can see here, you've got the ordering service endpoint. So when you running your client needs to know where the ordering service endpoint is to interact with it. When you create that VPC endpoint to go access the provisioned resources from your Fabric network, this is part of the input you use when creating that VPC endpoint. This is the service name. And then here you can see the members that are created. In this case, there's one member in the network. I own it. And I can go take a closer look. Here's the endpoint for the Fabric CA, so you configure your client to utilize this endpoint to say enroll new users, register new users, or enroll and get the certificates for a user to then interact with different applications on the network. And then I've created one peer node, and here's the peer node endpoint that once again you configure your node to use. One thing to remember is when creating the security groups for your client machine on EC2 that you own to interact with the components that are created in Managed Blockchain, make sure your security group is open to the right ports. That different peers have different endpoints and different ports. So you just want to make sure that that security group has the correct settings that you create. Before we go back to finish with the slides, wanted to show you an example. This network's deleted, but this network has 4 different members in it, and 2 of them I don't own. These are other AWS accounts. And if you wanted to invite a new account, right now in the preview it's quite easy. You just put in the account number, and assuming that they're also part of the preview, they'd get an invite, and the invites would show up here. But coming soon is our voting API to enable the network to vote on who to add and who not to add. All right, so that was a quick overview of the Amazon Managed Blockchain console, or the current features that are available in preview at this date. And so now we'll switch back to the slides. So we've got a couple minutes left. I want to quickly talk about how to get involved in the preview. So there's a link to the preview that I'll include later in this on one of the last slides in the presentation, but also you can go to our Amazon Managed Blockchain webpage. There's a link there. You can sign up, make sure to add your AWS account and the relevant information, and we add new accounts each week. There's resource limitations. You can see here one network and some other ones as well. Right now also it's free, that we're not currently charging in the preview. Here's some links to resources, the preview sign-up page or documentation, the Fabric workshop on the database blog, that's the second to last link, is really useful in understanding some of the Fabric fundamentals, and also just reading the open source Fabric documentation is great as well to learn a little bit more about what the framework can do. So please join our preview. We'd love to work with you. Definitely reach out, and we'd love to hear about your use cases, and if you have any feedback as well, we'd love to hear it. And we've got a variety of different customers across healthcare, telecom, supply chain, financial services, companies large and small, experimenting with us to really understand how decentralization and blockchain can enable their businesses. So thank you so much for your time and for joining this presentation. Feel free to email me, my email below, or Amazon Managed Blockchain help, and I'll leave it open to some questions to close the session. Thank you so much.